Okay, the number of cows in a herd each month follows the pattern 55, 58, 61, 64, and so on. If this pattern continues, how many cows should there be in the herd in 40 months? Okay, so this would be month 1, 2, and then 3, and then 4. I'm going to write that out down here. And then 55, 58, 61, 64. Okay, let's look at the pattern here as you're moving along here. Plus 3, plus 3, plus 3. So you're adding 3 cows every time. That means your rate of change is 3. Okay, so in terms of a linear function, that means you're going to have f of n equals 3n, because 3 is your rate of change, and then plus some we don't know. So this is a linear sequence, and it's going to follow a linear equation of, say, y equals mx plus b, but we're doing f of n equals 3n plus b. So this n is the input, f of n is the output, b is the initial amount. And the important thing here is because you have plus 3 each time for a rate of change, you're multiplying 3 times the input variable. That's the pattern for a linear function. Okay, so how do we figure out what we're adding each time? What I like to do is I like to just pick the first term, nice and simple. The output is 55, and the input is 1, then plus b. So now we can just solve for b and then finish writing our little rule here. So 55 equals 3 times 1 or just 3 plus b, subtract 3, 52 equals b. Okay, so f of n equals 3n plus 52. So why am I going through all this trouble to write a rule? Why don't I just list out the numbers? 55, 58, 61, 64. I know I'm adding 3 each time. If I could just write them out, I could write 40 numbers and get the answer. Well, sure, you can do that. I just think this way is a little more efficient and also shows you're a little bit smarter than the average bear. So I'm doing that. Now all I need to do to find out how many cows in 40 months, input a 40 right here, see what I get. So f of 40 equals 3 times 40 plus 52. And I'm going to get my handy calculator, figure out that answer. So we're going to do 3 times 40, then plus 52. $172 means we're going to have 172 cows. Okay, so let's take a look at this again. The number of